Use the conduction equation to determine the unit of thermal conductivity. In Part A, we want to express it in terms of the fundamental base units. So the conduction equation, Q over T, is equal to K A delta T over L. So when you rearrange this equation for K, the thermal conductivity, you get QL over little t A delta big T. The little t is time, the big T is temperature. When I put this in terms of its units, Q is heat, so that's measured in joules, times L, which is length, is measured in meters, divided by time in seconds, area in meters squared, and the change in temperature as either Celsius degrees or kelvins. We can break this down further, since a joule is a kilogram meter squared per second squared. But first, we can cancel out that meter with that meter. So now we have a kilogram meter squared per second squared over second meter Celsius degrees. And you can see that the meters, one of those meters cancels out with that meters, and the seconds squared will shift down into the denominator along with that seconds. So we're left with units of kilograms meters divided by second cubed Celsius degrees. Or we could say kilogram meters per second cubed Kelvin. They mean the exact same thing. In Part B, the unit is often expressed in such a way that it contains the unit of power, so express it that way. So we can actually go up to this part right here, where we said the units were joule meters over second meter squared Celsius degrees, and one of those meters cancels out. And then if you remember power is equal to work over time. So the unit of power, which is 1 watt, is equal to 1 joule per second. And you see in this equation, in this thing for units, we have a joule per second. So we can write this as a watt over meters Celsius degrees, or watts per meter Kelvin.